at certain temperature, let's say 25 degrees Celsius, that looks like the formula is that. Now, what this means? There is one thing, obviously, everybody can see. Because you have 9.756 multiplied by the hydroxy concentration, compared to only 0.250 multiple proton concentration. So the first thing, the impact of hydroxy concentration is almost 40,000 than the proton concentration. Second, this is hard to see. Every 10 degrees Celsius increase, the reaction rate increase by 1.5 to 3 times. What this means, if you're using a hot water, it will be more become a beta D-glucopyranose compared to Z alpha. And we already know in the food products, so naturally, 64% of beta, 36% of alpha. The last one, the minimal rate is at pH 2.5 to 6.5. So usually, if you keep the sugar, glucose concentration at a little bit acid environments, it's a very minimal rate. This happens usually in acid environment. Okay, by the way, when we talk about here, the 90-degree turn, usually that happens is in acid solution. Okay, the experiment is did in acid solution. So that's the Mortari rotation, what it talks about. Okay, last thing we want to talk. This is number 3, 4. It's number 4. Last one we're going to talk about number 5. Why? Well, we want to talk about that topic. We were food microbiologists. We also we also learn food chemistry. But eventually we are still food microbiologists. Which one related to what we're learning is bacterial media. So we want to explain something to you, you can understand it well. So let's go back to talk about that glucose, okay? We draw one more time. We draw one more time. The reason is we want to show you something. It's very easy, but you probably not recognize. Even you're working in the lab the whole day. Very similar to lipids. Sugar, let's say this is a glucose, can also go in through an important reaction called hydrogenation. What this means, simply you're adding H2. Okay, when you add H2, what it looks like? That's a magic. CH2 OH. Everything else stay the same. Okay, once this happens, what are the things you see? Let me finish it. Once you have this one, what are the things you see? They are all OH. Now what this one? That's sugar alcohol. Now what this one called? If the glucose going through hydrogenation process will become sorbitol. Sorbitol is a sugar alcohol. From dietetic nutrition standpoint, diabetes patient can eat it because better for the concentration of the glucose, the sugar concentration control. Although there's a debate about that, but we don't care about these. I said we're microbiologists. What we care? Did you ever heard sorbitol McConkie? We have a traditional McConkie. If you taking my class, we talk about the traditional McConkie. The sugar is lactose. So there should be lactose in McConkie. People think you are very smart, so they took this out. But the sorbitol McConkie, instead of you have a lactose, you have a sorbitol. Why this is important? This could differentiate E. coli 0157 H7 versus non 0157 Shigella toxin creating E. coli. The reason is the bacteria could use sorbitol during fermentation. If McConkie agar, this is pink, this is colorless. Sorbitol McConkie for non-0157 Shigella toxin generate E. coli, that is pink. In other words, on McConkie agar, this non-0157H7 is colorless. A very easy comparison. Okay. Okay, another example, we're not going to repeat it. Glucose and the mannose, the only difference is carbon number 2. Okay, if I have a mannose, I'm going through hydrogenation process. What it becomes? That's the one everybody heard, mannitol. Then comes out with another important agar, mannitol salt agar. Why it is important? This used to differentiate Staphylococcus aureus versus non-aureus Staphylococcus. Because Staphylococcus aureus is mannitol fermentation positive. That's pink. Oh, sorry, that's yellow column. That's mannitol fermentation positive. Others, colorless. Mannitol fermentation negative. Just a couple minutes left. We're going to talk some other things. That is important because we are microbiologists and it's a bacterial media you in the lab. You're just dumping the water solution and autoclave that makes the media, but there's lots of the chemistry behind it. Because when I prepare the class in here, I think it's better we introduce you. What is sorbitol, what is mannitol? It's a sugar alcohol. So that's a good combination with microbiology and also with the food chemistry. Okay, I'll simply just turn the camera go the other side. Then I will talk last one, then I will let you go. Okay, what are the last one? That's also related to the microbiology, but I want to, since we talk about the sugar, we're going to spend time talking about it. we talk about cell wall, bacterial cell wall, peptide glycan. Is that right? That's one of the theory for gram-positive, gram-negative bacteria. Then we talk about the cell, bacterial cell wall, peptide glycan composed by N-acetylglucosamine. What's that? I never teach about the chemical structure in my class. In the general microbiology class, I want to talk about here. That's not difficult. That's almost the same as a glucose. What's the difference? That's carbon number 2. That's all. That's N-acetylglucosamine. Okay, what is the other one? N-acetylmuramic acid. What it looks like? This is the same. That's no difference. These are that's all. So that's very interesting. Let me double check that one. Because I'm talking about the whole day. Yeah, only one, some mistake here. That's all. That C needs to be gone. That's H needs to be gone. Sorry. That's very, yeah, that's gone. The R goes here. These are the things are important with modified sugar. That's why I simply say this is modified sugar, because that's glucose add a glucosamine amino acid group, and this is amino acid group at the muramic acid itself. So that's very interesting when you see the chemistry is the bottom of all the classes. That's the reason. You didn't notice that. I didn't notice that when I go ahead to learn. You look at that XLT4 agar. If you are a PhD student going through qualified exams, that's a good question. What does XLT4 means? X is xylose, that's right here. So that's a 5 carbon pentose. It's an aldose. That's a lots of questions could come out of that. What is L? It's a lysine. It's an episode of amino acids. That's widely existing in the milk powder. Easily happen is Maillard reaction. That's turgid-4 is a selective ingredient. If you are making XLT4 agar without T4, it's just a differentiated media. You're not going to see it's a selective. Everything could grow. And because of the turgid-4, it make it very selective. So you can see here, we learned XLT4. We learned N-acetylglucosamine, N-acetylmuramic acids. We also learn mannitol salt agar. We get the bottom of what is mannitol, a sugar alcohol, coming from mannose. And we also talk about sorbitol macanthi agar. The sorbitol is a sugar alcohol of glucose. So all these knowledge, we could be combined. That is what a PhD training for. Okay, so it's a very important topic. We talk about the monosaccharides of the carbohydrates. Okay, Thursday there's no class because it's a research day, but don't forget, you are made on exam questions as a pair will be due by next Tuesday. So you're gonna give me your sample of the exams, and I'll do some grading and return to you, and then some of you can present at the end of the semester. Okay, instead of you present a literature, you can present the exam papers, what you did. Okay, very good.